You know, every once in a while, a week comes along that just feels different. Like a whole decade of progress just got crammed into 7 days. Well, in the world of AI, we just had one of those weeks. It was this incredible moment where the tech took several massive leaps forward, all at pretty much the same time.
Yeah. This quote just nails it, doesn't it? It perfectly describes what happened. Because this wasn't just one company hitting a home run. No, this was a full-on surge from, all the big players. We're talking Meta, Google, Microsoft, and ByteDance. And they were all pushing the boundaries in completely different directions at the exact same time. It was wild.
So, what we're going to do in this explainer is break down 4 of the biggest breakthroughs from that week. We're going to look at an AI that sees like us, a tiny AI brain for your phone, a bug-hunting AI agent, and even a whole new language for AI prompts. Let's get into it.
All right, first up, Meta. They are tackling something huge with this project called Dino V3. I mean, their goal is one of the biggest in all of AI. Really, they want to give machines a sense of sight, but not just like a camera recording pixels. They want it to be more like our own eyes, something that can genuinely understand and adapt to a world that's always changing.
So how are they doing this? Well, the magic ingredient here is something called self-supervised learning. Now, think about the old way. You'd have armies of people painstakingly labeling millions of images. This is a cap. That's a bridge. This is a stop sign. It's slow. It's tedious. With self-supervised learning, the AI basically teaches itself to find patterns in all that data. And let me tell you, this isn't just a small improvement. It completely removes the single biggest bottleneck we've had in training visual AI for years.
And the difference this makes, it's just night and day. The old way, super slow, crazy expensive, and totally held back by how many humans you could throw at the problem. But this new self-supervised way, it just unleashes the AI. It can now learn from the billions of unlabeled images that are already out there on the internet. This makes the whole process incredibly fast, and, well, it's just massively scalable.
And when I say scalable, I'm not kidding. Just to put this into perspective, the previous model, it was trained on about 142 million images, which is already a lot. But this new one, get this, it learned from 1.7 billion images. That's not just an increase, that's a whole new ballpark. A leap that massive in data gives it a fundamentally deeper, richer understanding of our world.
The model itself is an absolute beast too. It has what's called a frozen backbone with 7 billion parameters. Okay, so what does that even mean? The best way to think about it is like this. This frozen core is an expert that's already learned all the universal rules of sight. It just gets it, so you don't have to reteach it how to see every single time you have a new job for it. Nope. Instead, you just give it a tiny, lightweight adapter, kind of like snapping on a new pair of specialized glasses for each new task. It's just an incredibly clever and efficient way to do things.
And look, this isn't just some research paper stuff. It's already being used out in the real world. I mean, NASA's JPL is using it to help the Mars rovers see their way around. The World Resources Institute, they boosted their accuracy for measuring tree canopies by a whopping 70%. Just think about it. Imagine a robot walking into a brand new, unfamiliar factory and just instantly getting the layout. That's the kind of crazy adaptability we're talking about here.
Okay, so while Meta was going absolutely massive, Google, well, they went in the complete opposite direction. It's pretty fascinating, actually. They focused on making AI so small, so ultra-compact and efficient that it could live right in your pocket. We're talking about their new Gemma 3 model. So what you're seeing here are 2 totally different philosophies clashing in a good way. You've got Meta building the 7 billion parameter universal brain for huge cloud systems. And then you've got Google crafting this tiny 270 million parameter model that's designed from the ground up to just run on your phone. It's really like the big brain versus tiny genius story of modern AI playing out right in front of us.
And this is the truly jaw-dropping result of all that focus on efficiency. Check this out. This model is so ridiculously optimized that you can have 25 full-blown back-and-forth conversations with it on a new Pixel phone and it will use less than 1% of your battery. Think about that. It's so efficient, it probably won't even register on your battery usage screen. That is just insane.
So why does this matter so much? Well, the advantages are huge. First off, since it runs completely on your phone, your data never has to leave your device. It's not being sent to some cloud server somewhere, which is a massive, massive win for privacy. Plus, it's super fast to customize. You could literally have a whole collection of specialized AI models right on your device, maybe one for helping with customer service emails, another for legal stuff, and just flick between them instantly. The possibilities are really cool.
All right, so we've seen massive AI and we've seen tiny AI. Now let's switch gears and look at a highly specialized tool. ByteStance just announced something called ToolTrain, and this is an AI framework built to solve what is, for any software developer out there, one of the most painful problems imaginable, finding that one tiny bug hiding in millions of lines of code. And that really is the question, right? How on earth do you find that one bug? The official name for this task is issue localization, but a better description is finding a needle in a digital haystack the size of a mountain. It's not just about searching. It requires this long chain of reasoning, following little clues from one file to another. It's the kind of complex detective work that even really big, powerful language models have a tough time with.
So ByteDance's solution is really clever. It's a two-stage training process. Think of it like this. In stage 1, the AI basically goes to school. It learns the basics of how to use code searching tools by looking at a bunch of examples. Then comes stage 2, where it hits the gym. It sharpens its skills using reinforcement learning, which is basically just learning through trial and error. It gets rewarded for making smart moves. And this is what teaches it to think like a detective, to be strategic, instead of just wandering around aimlessly through the code. And does it work? Oh yeah, the results are seriously impressive. With this ToolTrain framework, a relatively small 7 billion parameter model was able to outperform models that were more than 4 times its size at the specific task. It's just a perfect example of how working smarter with better training can totally beat raw brute force.
And that brings us to our fourth and final breakthrough, this one from Microsoft. Now, this one's a little different. It's not another AI model. Instead, it's a foundational tool that could completely change how everyone builds things with AI. It's called PalmAll.
Honestly, this quote is the best way to get it instantly. Think of it as HTML, but for LLM instructions. Perfect. POML, which stands for Prompt Orchestration Markup Language, is a structured way to write prompts for AI. You know how before HTML, the web was just a mess of text? HTML brought structure and order. Well, POML wants to do the exact same thing for the messy, often chaotic world of prompt engineering.
And I mean, just look at the difference. It's night and day. On the left, you've got the old way, this big, ugly, chaotic block of text where all the rules and examples are just jammed together. It's a nightmare to read and even worse to try and update. But then on the right, you have PalmAll. It's clean. It's organized. You have these simple, clear tags for the AI's role, its task. Everything is laid out logically. Suddenly, your prompt is readable, it's reusable, and frankly, it's professional. And this thing is seriously powerful. It actually separates the logic of the prompt from how you want the output to be formatted, which, if you know web development, is exactly what CSS does for HTML. It's a huge deal. It even supports stuff like variables and loops, so you can create really dynamic prompts. You can embed data directly, documents, tables, even images. Best of all, they've made it open source, and there are already tools like a VS Code extension to make it fit right into a developer's workflow.
So let's take a step back and look at the whole picture. When you put all 4 of these stories together, you see this incredible trend. The world of AI is accelerating on every single front, all at the same time. It's getting bigger and more capable thanks to Meta. It's getting smaller and way more accessible thanks to Google. It's getting sharper and more specialized for tough jobs, like we saw from ByteDance. And it's becoming fundamentally easier and more professional to build with, thanks to Microsoft. It's pushing out in every direction at once. Which really leaves us with one last big question to chew on, right? We've got these major advancements happening in scale, in efficiency, in specialization, and in the very tools we use to build, all at once. So which one do you think is going to make the biggest difference in the next couple of years? Is it the giant AI that can see, the tiny one in our pocket, the expert bug hunter, or the new language for building it all?
It's an amazing time to be watching all this unfold. And honestly, the pace of change is just breathtaking.